flow, plane flow, past closed body shape. A variety of closed body external flows can be constructed by superimposing a uniform string with source, sink, and vortices. Let me write source. We have elementary, streams, sinks, and vortices. The body shape will be closed only if the net source outflow equals the net sink inflow. The Rankine oval is the first body shape that we are going to study. The Rankine, right? Oval, a cylindrical shape called a Rankine oval, which is long compared with its height, is formed by a source sink pair aligned parallel to a uniform stream. A cylindrical shape called a Rankine oval which is long compared with its height. Is formed by a source sink pair aligned parallel to a uniform string. The Rankine oval, which is shown in this picture also. Let me provide the picture here. So from previous we can write the sign function for the source sink and uniform stream psi equals to uniform stream ux, and source sink as we obtained before is tangent inverse of the distance between source and sink, which is 2a minus a2. This shape shows our stream. In this case we have an oval, and also we can calculate each point position with this location and geometry. When streamlines of constant size are plotted, an oval body shape appears as shown in this picture also. The half length L and half height h of the oval depend on the relative strength of the source and the stream. That is the ratio which equals 1 in this picture. The ratio of the sink and source strength on the uniform string velocity. In this picture it is equals to 1. The circulating streamline inside the oval are uninteresting and not usually shown. The oval is the line of streamline equals to 0. There are stagnation points at the front and at the rear point. Here, stagnation point here. X and points of maximum velocity and minimum pressure at the shoulders of maximum pressure at minus positive edge of the oval as shown also in this picture. So we have H, stagnation point here, stagnation point here, V max, P min, V max, P min. All these parameters are a function of the basic dimensionless parameters. So we have a dimension less parameter, which is a strength on which we can determine from the previous equation. We have also this relation for an oval created by a stream and two sink and source with a strength of m. The first relation is h on a. Let me provide the picture also for more description. H on A, 2m on a streamline velocity, and the distance between two sinks and source. This distance to the origin here, source and 6a. We can also obtain a relation between L and the distance of sources to the origin and the strange. And also the relation of here, the maximum velocity of the on the oval on the stream to m as we increase from 0 to large values. Let me write increasing m on from 0 to large values, the oval shape increasing in size and thickness from a flat plate of length 2a to a huge, nearly circular cylinder. So we can increasing this dimension less quantity, the oval shape in size and thickness from a flat plate of length 2a to a huge, nearly circular cylinder. Nearly cylinder. This is shown in the table 8.1 in the limit as, let me write the limitation for when we have m on infinity, then L on H tends to 1. And this is equivalent to flow past a circular shape. All the Rankine oval except very thin ones have a large adverse pressure You can also take a note on Rankine ovals except very thin ones. Have a large adverse pressure gradient on their leeward surface. On their leeward surface. It means adverse pressure on the leeward all the Rankine ovals bodies. Thus, boundary layer separation will occur in the layer with a broad wave flow. As a result, we have separation on in the rear with a broad wave flow. With a broad wave and the inviscid patterns is unrealistic in this region. Is unrealistic in that region. Flow past a circular cylinder with circulation is the next subsection in this section. Flow past a circular cylinder with circulation.